Hi, welcome to BikeGremlin YouTube channel, and today I will talk about how to shift gears on a bicycle. That is something that many experienced cyclists know and that some unexperienced don't know, and also this video might show some info that even the experienced cyclists don't know or don't know in all the details. So I will create in the timeline of this video like small chapters, so you can see it in the timeline and skip to the parts that interest you, so you don't have to go through all the talking. And let's begin. First thing I will tell you is a shocking fact you would not believe. Practically every bicycle has only about 10 different gear ratios. Okay, I'll put this, don't need it right now. What do I mean by that? Let's take a look at this bicycle. This bicycle has 3 chainrings in the front and I think about 9 in the back. 1, 2, 3, 4, 5, 6, 7, okay, and 9 in the back. And when bicycles are sold, they are sold like multiplying the number of chainrings in the front with the number of the chainrings or sprockets in the rear. So this bicycle would be like 27 speeds. Well, that is not really the case. It sounds good for marketing, but it's not really the case. Why? Because when you use a combination of the largest chainring on the front with the largest chainring on the rear, you get roughly about the same gear ratio. I will put a link to my article explaining gear ratios and how difficult it is to pedal, basically, to put it simply. Anyway, I'll put that article in this video description. Okay, but the same gear ratio can be achieved if you put your chain on the smallest of the 3 chainrings in the front and also on the smallest of the 9 chainrings in the rear. You get similar difficulty of turning your pedals and going with by similar speed. So you don't have the entire number of combinations available to give you different gear ratios. There might be just slight difference, but it's not really relevant. Another thing to consider, why I chose this example, is if you want to achieve that kind of gear ratio, in both these examples that I just told, the chain would be very severely angled, going from the inside of the bicycle to the complete outside, or if we are on the largest chaining on the front and the largest at the rear, then it's going the other way, but it's at the greatest possible angle, which is not very good because it makes the chain wear exaggerated and the chainring wear also exaggerated, and it is more likely to have your chain skip or get off a chainring or a rear sprocket when it's ridden that way, especially under force and if you're riding on a bumpy terrain. So the best way to achieve that gear ratio is to, on a bicycle with 3 front chainrings, to put the chain on the middle chainring in the front and choose one of the mid chainrings at the rear that provide the closest gear ratio that you want compared to those examples that I've given. Now, trying to explain this, it's very simple when you understand it, but the first time this was explained to me, I had to sit down and think it over, then try it on my bicycle. At that time I had the 3x6 drivetrain, and even that was still confusing. But this, what I'm explaining, goes in the same way for 3x11 or 2x11 or 2x12 with the newest Shimano my MTB drivetrains, and also for few rears at the back. It also goes for 2x6 or 3x6 or 3x7, whatever combination. The principle is the same, and I hope this will help you understand it. You can completely disregard these numbers. Okay, now let's look at this picture in the middle. You can completely disregard all the numbers. No matter how many chainrings you have at the front, and regardless of how many chainrings you have at the back, when you are on the innermost chainring at the front, you will use the innermost part of the cassette. So if you have 6 sprockets at the rear, you will avoid using the smallest 2 at the outside of the cassette. If you have 11 or 10, you will avoid using the outmost 3, because total cassette width is relatively similar, the number of sprockets increases, and when that happens, their spacing decreases, but the chain angle remains the same. So we are now concerned only with the chain angle. Here I don't know if it's visible. Just a minute. Here, let's try now. Okay, let's try to draw the chain angle. Okay, it's not the best drawing in the world, but I will post a link to my article that explains this also with a better picture. Anyway, so we are looking to avoid having our chain severely cross-chained, as if it would be if we went with all the way to the smallest. Here, this is not the realistic ratio of sizes or distance, but it is like looking the bicycle from behind, parallel to the longitudinal length of the bicycle. Anyway, but even in real life, you can expect the severe cross-chaining combinations to start catching on to the adjacent largest chainring, or to start scratching on the front derailleur cage, or so you can have your chain start scratching here in some combinations, especially when being on the largest in the front and using some of the largest at the rear. That is why you don't have to be concerned with the number of gears. Just avoid using the outermost rear sprockets when you are on your innermost chaining. And also, let's look at this picture. Okay, sorry, this one. You should also avoid using the innermost, like 30% of the sprockets, no matter how many gears you have. Like if you have 6, it's the innermost one. If you have 10, it's the innermost 2 or 3. But you should avoid using the innermost sprockets on the rear with the outermost front chaining. Why I'm using this innermost and outermost? Because some systems have only 2 chainings at the front, and we'll get to the 1X system, 1 that only have 1. Okay, but for now we are sticking with 3. So that's what you avoid. And when you are on the middle chaining, like let's take this picture, you should avoid some 10% of the outer and 10% of the inner. Again, we're looking to have a relatively parallel chain line. We don't want the chain to go at a severe angle. That is the whole philosophy. Now with two chain rings in the front, when they are aligned properly, that is called chain line. It means having the middle section of the front chainring set be in line when you're looking parallel to the bicycle with the mid section of the cassette. That is getting the chain line right. It can be sometimes off by a few millimeters. Sometimes you do that deliberately. I also have a article explaining chain line. I will link that as well in the video's description, but this is the basics. We'll show it later on the bicycle. When you have only 2 chain rings, then it is similar, only you don't have this middle one, and these outer 2 are a bit closer together, closer to the middle. And in that case, the philosophy is the same. With the outermost, you don't use about 30% of the innermost rear sprockets, and with the innermost chaining, you don't use about 30% of the outermost sprockets. Now, my videos are all very long and very detailed. On the opinions are divided. Everyone thinks that sucks, and I think it's brilliant. So I will now discuss a caveat that is very, how do I say, it's modern, it's now happening, it's current. And that problem is the modern 2x, or especially road bike chainrings that have the largest chaining of 50 teeth and the smaller one 34 teeth. It is designed to allow a wide range of gears, but with using only 2 front chainrings. Now I will not discuss why I think that's like a goal in itself. A triple front chaining does the job, and I'll link an article on my website about that, but it's not modern. It's modern to have fewer chainrings. Okay, so they made that combination, but the problem with that combination is that for a wide majority of people, when they are on the front chaining with 50 teeth, they usually have to go all the way angled on their cassette, because if they use one of the smaller sprockets from that largest front chaining, they cannot turn the pedals easily enough on flats, only on downhills. On the other hand, when they are riding on flats, if they put the chain on the smaller 34 toothed chainring, they would have to move the chain at the rear all the way to the smallest few sprockets, this time in order to make the pedaling be difficult enough so they don't just spin in 200 rounds per minute like a rabbit. So that combination is not very practical, and a better solution is to have a 46 by 30 combination of front chainings, which is now a bit less available, at least in my country, but I think that is a more reasonable combination with the cassettes that are available. What do I mean by that? Cassettes start from 11 to, or from 12 teeth usually. Then they go to however many. On MTB cassettes it's now over to 40 teeth, and on road bike cassettes it's 32 or 28 or something. Hi. And the problem with that 50 by 34 crank would be solved if the cassette was made to be like common sense, like start with 14 and then have 15, 16, and then 2 teeth gaps, and then all the way to, I don't know, 32 or even 34. That would bring a bit more weight, but it would also bring, because more teeth are engaged, longer durability, longer life of chains and cassette, especially cassette chainings, and it would make those cranks more useful, and the things would be a bit longer lasting. So that would be a good solution, but it's very difficult to find such cassettes. They are sold as junior racing sometimes for road bicycles, and they cost a lot more than the, say, ordinary cassettes. So every cassette, every chaining that has below 13 teeth has more mechanical losses, because chain gets at a very awkward angle bent, and when the force is applied, and very few teeth of the cassette are put in, are doing the work. Okay, so now we'll try to show it how this works, and I will also explain another important thing about changing gears on a bicycle, and especially when we are talking about bicycles with derailleurs. Another important thing is to not put a lot of load on your pedals when you are changing the gear. So if you are loading your pedals to go faster and faster, or to keep your speed, when you want to change gear, you should make that turning of the pedals a bit slower, so that it is not, so that no pressure is felt on the pedals against the rear wheel drag. I'm not sure if I explained correctly, but here we are winding up, and then if I want to switch gears, I will just slow down a bit, so that pedals are turning slower than it is needed to further increase the speed of the wheel. So there is no load on the front or rear chainrings, and then after I finish the changing gear, I can continue putting more force. Let's see what happens if I'm loading the pedals while trying to change gears. Okay, I will hold and press the rear brake, and now I will try to shift, and let's see what happens. If I destroy my friend's chain, I'll get a new one. It's very difficult, and it's getting stuck, not just because here you can see, you can catch this with the camera, I hope. From this angle maybe it's better. Here especially is critical, this is critical when shifting on the front. You see how the chain is stuck here and trying to move to the largest front chaining, and when the force is applied, this is all under tension, and you can easily break the chain doing this. So it's not a very wise thing to do. Similar problem happens when you are going up a hill and you forgot to downshift in time, and you need to make the gear ratio lower, and so you're trying to shift to the larger chainings at the back, but if you put a lot of force, it does put a lot more strain on the chain, and on some systems it can cause the chain to break even when shifting at the rear. I wrote a special article on my website about the systems that have only one chaining at the front, and of course with those systems all this starting story about chain being at an angle and how to avoid cross chaining to get the desired gear ratio is of course moot. It's not relevant because you are bound to have your chain highly angled when you are using the fastest or the slowest gear on one by drivetrains, and that is one of the downsides of the one by drivetrains. They are, I like to joke, they are solving a problem that doesn't exist, but in some uses they are useful, like if you ride in extremely muddy conditions and so on. It's all explained in that article, so I'm afraid this video is already probably too long. And I'm not sure how well I've explained this, but the basic is to avoid cross chaining and to avoid putting too much pressure on the pedals when pedaling. To avoid cross chaining, you just have to mind how many to mind and to avoid using the innermost rear sprockets with the outermost front chainings, and vice versa, to avoid using the outermost cassette sprockets with the innermost front chaining. And for those that have 3 chainings up front, for the mid chaining you'll use the middle section of the cassette. So I could have made this video last only 1 minute, but why not bore you to that? I will put the links on our video sections in the timeline so you can skip. I hope this has at least helped someone, that it's not too badly explained, and thank you for watching and see you. Bye.